All right, for all those missing people here, so we have to enjoy that we're here. So we have to proclaim that I am here. So class, yes. What do you mean sorry? You say yes. Say it. Okay, everyone participated, especially when certain other people weren't here, to try and make sure that they're included in the class. So, yes, your participation is necessary. All right, is the function continuous on the closed interval? So what that means is every single point from -2 to 2 going to be in the domain of this? Can I plug in -2? What is -2 squared? 4, right? So 4 minus 4? 0. Is 0 a number? Am I allowed to have 0? The square root of 0 is 0. There we go. So is that one allowed? Yeah, good. What about the other side? That's going to give me 0 again, right? Is there any place within the graph from -2 to 2 that this is going to be undefined or does not exist? No. So we're not looking for a solution. We're not looking for a solution. We're looking for lack of solutions here. Places that my statement will fail. That's what I'm looking for here. So, is this continuous? You say, yes. Definition: continuity on a domain. F, a function is continuous on its domain if it's continuous at every number C in the domain. Determine the function blah is continuous on its domain. Is this continuous? Can I have 1? I could plug in 1. Can I plug in anything below 1? No. Because why? Okay, so 0 minus 1 is? What's 0 squared? 0 times anything is 0. So does that one work? 0 works for some reason, but does 1/2 work? 1/2 doesn't work, does it? Because 1/2 minus 1 is -1/2. 1/2 squared is 1/4. 1/4 times -1/2, -1/8. Can I have a negative inside a radical? No. So over this domain, it's not going to be continuous here, is it? No, because for some weird reason, it works at 0. But nothing else under 1. So it is not continuous on its domain. Polynomial function is continuous on its domain, all real numbers. A rational function is continuous on its domain. If a function is continuous on an interval, its graph has no holes or gaps on that interval. if a function is continuous on its domain, it will be continuous at every number in its domain. Its graph may have holes or gaps at numbers that are not in the domain. So, if we're talking about the domain, we have to be very precise of what the domain of this one would be. I would say that my domain of this would start where? Where was I saying I'm allowed to have it? At 1, right? I could have 1 because that would give me a result of 0. So I can have 1. So it would be a bracket 1, 2, infinity. There's no other places in which that on this domain it's going to work out. So it would be continuous over that. Because in between 0 and 1, there's nothing there, right? So continuity of a sum, difference, product, and quotient. If the function g and f are continuous at number c, and if k is a real number, okay, k is the constant that I'm multiplying by, so it's like 5 times something. Okay, that's important. Then the function f plus g, f minus g, f times g, and k times f are also continuous at c. If g of c is not equal to 0, then the function f divided by g is continuous at c. So what that is saying, if I are continuous plus a continuous is continuous. A continuous minus a continuous is continuous. F times g, continuous times a continuous. Okay? Same thing goes all the way up until f divided by g, where g cannot equal 0. I cannot have 0 in denominator. So, continuity of a composite function. If a function is continuous at c and a function is continuous at g, then the composite function f of g of x is continuous at c. It is broken down into different parts of this. So, f of g of x. That means I'm evaluating at x for g, and that answer is my new x going into f. Does that make sense? So input, output. The input for g is x, right? The output for g is now the new input for f. You're looking at me crazy. No? Maybe? Possibly. Possibly I am crazy. There is a good chance, okay? I did wake up this morning and decide to put my socks on backwards today. So, now, are you okay with this? No problem? Okay, you just felt like looking at me all crazy? Okay. Okay, same thing goes the other way. So if this does work, this will work, and of c, for whatever c value, g of c, so my input is c, it's going into g. My output of g is now going into my f, which is going to give me my final output. And that would be of my f of g of x. I hate looking at that because it always says fog. Okay? I'm like, dude, making me all weird. Maybe, possibly. Okay. Theorem, continuity inverse function. If f is a one-to-one function that is continuous on its domain, then its inverse, f to the negative 1, is also continuous. One-to-one means that for every x there is a single y. Okay? For it to be inverse, for every y there's only one x. That is going to be continuous. Okay, now, IVT, intermediate value theorem. This is actually one of the big concepts that's actually on the AP exam. Again, for those people that are not here with us right now, that are actually watching this video, they missed the analogy earlier. Okay, intermediate value theorem is the chicken crossing the road. So if the chicken starts on this side and ends up on that side, intermediate value theorem means at some place, somewhere, the chicken had to at least cross the road. There we go. That's the whole thing. Now, the path that the chicken's going to take is going to be determined if there is more than one solution or not. So, right here, let f be a function that's continuous on a closed interval from a to b, and f of a cannot equal to f of b. My starting side cannot be the finishing side. So if the chicken's on this side of the road and the chicken ends on this side of the road, I can't use intermediate value theorem and say that the chicken crossed the road. Maybe the chicken did. I can't prove it though. But if the chicken starts here and ends here, I have no proof to say that he did cross the road. If n is any number between f of a and b of a, f of b, then there is at least one number c in the open interval. That means somewhere in between, not equal to the ends. That's what the open means. I cannot be equal to the ends because my closed interval is my start and my end. So if I had closed on both sides, that would mean that he could start here and that he would also somehow cross here, somewhere in between. That doesn't work. So he has to be somewhere in between there, for which c is equal to n. So better result, suppose you climb a mountain starting at elevation of 2,000. Okay, here's my chicken. Okay, so let me see. There we go. There's my chicken. Starts at elevation of 2,000 meters and ends at an elevation of 5,000 meters. No matter how many ups and downs you take as you climb, at some time your altitude must be 3,765.6 meters or any other number in between there. So if he starts here, ends here, he must have somewhere, somehow, cross that line. Does that make sense? Now, be very careful about this. This is going to be going along with the other question. What about right here? And if I say that my chicken crossed the road, that looks like 3 times, right? Yeah, 3 times. Let me make that a little bit better. There we go. All right, right there. My chicken crossed the road 3 times. Yeah, I can clearly say that somehow my chicken crossed the road 3 times, right? So numerically, I'm standing on this side of the road. And I'm telling you the chicken crossed the road 3 times. Is there any other place besides right here it looks like that the chicken must have crossed the road 3 times? It really doesn't look like it up there, right? It doesn't look like it. It's kind of meh up there. But right here I can clearly see that the chicken crossed the road 3 times. So any altitude in between, let's say that is, I don't know, like 35 and like 3,000. Somewhere between 35 and 3,000, all those places I could say that the chicken crossed the road 3 times. But the road right there is asking those questions. Okay? Now, the AP question is this. This is the 1.3 homework AP 10. We're going from -2 to 2. And right here it's asking, so x is -2, 0, and 2. And my f of x's are 3, right here, close dot here, 2 is 2, okay? So, by this one right here, my intermediate value theorem, I know that somehow, no matter how I could look like that, right? So, with this AP question number 10, says the equation f of x equals 1 must have at least 2 solutions in the interval. If C is equal to, so the C value we're looking for I have choices, so it's either 1/2, 1, 3, and 4. All right, looking at this, so if my C value is equal to 1/2 and f of x equals 1 has 2 solutions, that means that there is somewhere it's going to cross that road, right? That's what that means. It's going to cross the road. So my chicken is going to cross this road. So if C is equal to 1/2, that would be right here. If it would be equal to 1, equal to 3, or equal to 4. Which one? I almost heard what you're saying. C, my x value is 0. And it's asking for what is C.
I thought it was 0, 0.
No. Vincent, what do you think?
Oh.
Okay, remember the road is 1. Here's my road. O-A-D, there we go. Okay, there's my road. For the chicken to cross the road 2 times, and me to prove using intermediate value theorem. So, think about this. I could say that this has 2 solutions. That means that the chicken crossed the road twice. Which one of these might work? That's going to tell me the path that the chicken took. At 1? Okay, let's see. So, you're saying that he went to 1 and then came over here. Yeah? Okay, so that means that the chicken crossed the road. How many times did he cross the road? 1 time. But right here it says you have 2 solutions. one doesn't work. Where else you think? Where at? 1/2. Let's see 1/2. So at 1/2, does this have two solutions? Does it cross the line, cross the road twice? It crosses here, and it crosses somewhere over here. That's how this works out for this to have two solutions here. Because he has to cross the road 2 times. So that means that this number here has to be somewhere down here. Somewhere below that. Because I can't prove, so right now for those people watching online, the road is right here to my right, okay? The chicken's starting here. If I'm plugging in the other numbers and I have 4, that means my chicken definitely is on the left side of me. And he ends on the left side of me, right? So he starts here, he's on the left side, and then he ends on the left side. That's important. So mathematically, I cannot show that he crossed the road at all. Same thing goes at 3. At 3, I'm standing here, the road's on my right, the chicken is actually starting here, he goes to my left, and then definitely ends back here where I'm at, right? So I can't draw a path to show that the chicken somehow must have crossed the road. Does that make sense? Okay. So 2 times mean he's down here somewhere, he goes down and back. If he touched it 1 time, one solution, that would be at 1 right here. That would be the one solution to verify that there is there. But if it says that there's 2 solutions, it needs to go down below. Does that make sense now? Does that help? Okay. So that's the reason why I wanted to say this type of thing until today. So I have, because we talked about other stuff with continuity last time, and today I wanted to say this, because usually this is like the larger concept. Yay? Are we good? Okay. Where are we at now? Use intermediate value theorem to show that has a 0 between 1 and 2. I will show you mathematically how to do this. Between 1 and 2. So let's do f of 1, 1 plus 1 minus 1 minus 2. What's that going to give me? -1. Okay. The other side, f of 2, plug in 2, that's 8 plus 4 minus 2 minus 2. So what's that going to give me? That's 8? Okay. So, has a 0 between. So, intermediate value theory says that if I start at -1 and I end it at 8, that means what? He had to cross 0 somewhere in between. Even though this is a 3rd degree, right? It's a 3rd degree, so it's going to go up, down, and back up again, right? It's positive. Yeah? So there might be multiple, but I can tell you there's at least one right there. There's one somewhere in there, and it must cross. I could not use this if I had -1 and -1, right? I could not use this if I had +1 and +8, right? I could not use intermediate value theorem for that reason. But this one does work out. So if I start at -1, I end at 8, the chicken crossed the road somewhere in between there. has 0 in the interval, use the intermediate value process approximate to 3 decimal places. Let's put this in the calculator. So my calculator's still not working, so I'm gonna bring up the other calculator that I've been using. So, cause you guys got the good calculator, I don't. What the deuce? Alright, so right here. And that was x cubed, right? I don't see the caret. Am I not? Oh, there it is, right there. Plus x squared minus x minus 2. Did I copy that correctly? Okay, good. There you go. So, here's what the graph looks like here. Now, I can clearly see the points here. This is a third degree, so it has this nice up and down. And right here in between 1 and 2, I can clearly see it does cross right there, right? So you guys can click on menu trace to be able to get yours to actually show where it's at. I should probably charge mine. I have another one here. I keep trying to turn it on every single day. I'm like, oh, yeah, I forgot to charge it. And I still don't do anything about it. And I believe our question says answer to what? 3 decimal points, right? And you come up with what? Like 1 point what? 2? I almost heard you. I could barely hear. I blew up too much stuff in my life. 06? Like that? Okay, what's the next number after that?
Oh, that's the approximation.
That is the approximation?
Yeah.
Okay, so it was 5 something, right?
5.
Okay, good. Just making sure, because a lot of people don't normally, I try not to assume that you rounded correctly, especially if I'm not looking at it. All right, there we go. And that's where the 0 is. And is that the last set? Yes, it was. So make sure everyone likes, shares, and subscribes. Anything else I need to say? Like, share, subscribe. Buy stuff from the merch store. There's a big discount on some of the Bobcat merch in the merch store. Okay.